Hi, my name is Nihira Hadawale, and this is my application HIVision. When you first go into the application, you're met with the landing page. This landing page provides the purpose of the application and explains the problem that HIVision is trying to solve. It gives the users an overview of the platform before they begin their analysis. You can also see the workflow of the application and explain the importance of HIV drug resistance and provides navigation throughout the site. Now I'll launch the analysis workspace. The first thing you see is the dashboard. Users can either manually enter HIV mutation codes or upload a file containing their mutation data. I have an example ready. Here you can see all of the mutation codes are ready, and you can run the resistance analysis. The results are very important as you're met with the mutation codes against the mutation database stored in the Flash backend. At the top, we immediately see an overview of the analysis, including analysis confidence, resistance probability, and the number of recognized mutations. As you scroll down, you can quickly see the importance of what HIV is, what the ARTs are, which is the therapies that fight HIV, and why tracking mutations is extremely important. As you scroll further down, you can see the structural binding affinity map. This visualization summarizes the predicted disruption caused by the detected mutations. As you scroll down, you can see the individual ones and see their disruption index. Instead of reading through multiple mutation records individually, users can quickly identify regions associated with higher resistance impact. Although it's called a structural binding affinity map, this prototype is a scientific visualization rather than a molecular docking simulation. The next thing you can see is the therapies. In the next tab open, when you open therapy, after the analysis is complete, HIVision automatically organizes the results into therapy recommendations. Instead of displaying mutation data, the application groups therapies into medications that should be avoided, used with caution, and potential options. The next thing I want to talk about is the mutation database. So this contains all of the curated mutation records used by the application. Users can search themselves which ones they want to see, and they can sort them by codon position, drug class, resistance category, severity level, supporting evidence, and just an overall description. The next thing I want to talk about is the research section. So the research section organizes mutation records according to the HIV gene they affect. Currently, we have 45 records, 3 genes, and 1 evidence labeled, and now you can see the impacts of your specific codes. As you scroll further down, you can see the mutations are grouped by biological target, making it much easier to study resistance patterns affecting reverse transcriptase, protease, integrase, and other viral proteins. The next thing I want to talk about is the AI assistant. So the AI assistant provides a conversational interface for interacting with the mutation database. For example, you can explain specific mutations and mutation codes, and it gives a very curated response based on the data already collected. The assistant is grounded in the application's database and is designed to simplify interpretation rather than replace clinical expertise. The next thing I want to talk about is the drug interaction checker. So when you open interactions in the database, you're met with a series of drugs in the regime. So you can click on multiple drugs and see just how they interact with each other. The drug interaction checker evaluates medical conditions using a curated interaction database. For example, HIVision identifies a known interaction and explains why it occurs and provides the appropriate recommendation. Alongside the integration checker is the mutation co-occurrence network. If you click on a specific node, it shows how a mutation, while each connection represents the curated visualization of how a resistance often develops through combinations of mutations rather than an individual mutation acting alone. The next thing I want to talk about is the reports. So this combines mutations, resistance probability, therapy interpretations, and just the overall findings to structure a report. This represents the final stage of HIVision's workflow and provides an organized summary of the analysis. So here you can see your detected mutation records based on your reverse transcriptase sequence that you pasted in earlier. You can see the prototype risk, the amount of mutations, and the scope, which is code matching. And if you go back to the dashboard, you can learn more about why HIV is very important to look for, especially the mutations. To summarize, HIVision combines mutation analysis and AI assistant explanations. Thank you.